So here's the sun, right? It's about 93 million miles away from the Earth. It's big, and it's got a lot of energy. Light is how energy moves through space. But the snag is, when light hits the Earth, the energy is all spread out. So we have to figure out how to collect it and concentrate it so we can use it. To get lots of power, we use solar farms. On some farms, thousands of mirrors focus sunlight to heat pipes filled with fluid. On others, rotating mirrors aim the sun's rays at a liquid-filled tank at the top of a tower. Both convert heat energy to electricity using a generator. And then there are huge farms of solar cells, collecting the sun's energy and turning it directly into electricity. But solar cells can work on a smaller scale too, powering everything from streetlights to houses to stores, even airports. But what about flexible cells that go where you go? Then you could charge your cell phone while you're on your way to meet a friend. Researchers at Arizona State University are looking to the solar experts, plants, to see if we can make solar cells that work better with your life. Brad, can you tell me a little bit about what kind of research you're doing in your lab?
Our group likes to focus on the first steps of photosynthesis, where plants take light and start converting it into energy.
In a plant, chlorophyll molecules absorb light from the sun and use that energy to move around electrons. Solar cells based on photosynthesis can be smaller, cheaper, and more flexible than the ones we have now. Most of the solar cells we use now are made from layers of silicon, engineered to make them positive or negative. When the layers are sandwiched together, the space in between acts kind of like a magnet. Light energy can excite electrons, making them jump into the in-between space, and its magnetic properties push them to the other side. Once the electrons build up, the negative charge makes them push each other through the circuit, creating an electrical current we can use. Brad is making colored dyes that help the solar cell absorb even more light energy, like chlorophyll does in plants.
We make more and more complex molecules for us to eventually try and get a very good mimic of what the plant does.
So what are we looking at here?
We're looking at different pieces of a dye-sensitized solar cell, showing kind of the different parts to form our solar cell. We have a very, very thin film on that. We cover that film with one of the dyes that we make that absorbs light very well. And if we clipped 2 wires to those pieces of glass and put it in the sunlight, we'd be getting electricity out of that. It's basically a stepwise process in research. You just never know what's going to work and what doesn't work.
In this case, you might need to collaborate with some other people that could give you ideas on how to do that.
A lot of people have different specialties, and they might be 10,000 miles away on the other side of the Earth at a different university, but they know how to solve your problem.
Collaboration is an important part of solving problems. Remember that thin film Brad was talking about? That's another thing that researchers are working to improve. So Brittany, can you tell me a little bit about the work that you're doing in the lab right now?
The goal of the lab right now is to make organic solar cells more efficient. And the work that I was doing to help this along was to take certain layers on a solar cell and try to make it so that they were bumpy. And what being bumpy does is it helps the interface between 2 surfaces have more surface area.
So there's more surface area, but the 2 surfaces still have to be close enough together for the electrons to jump.
Yes, so they are limited in the distance they can move by the material that we're using. So we have to make really thin solar cells, but when it's really thin, you can see through it more easily. And so if you can see through it, that means the light's not getting absorbed by the material. So what we want to do is be able to have it thicker so more is absorbed from the sunlight and you get more power. I wanted to do some work over the summer that would give me some experience in a chemistry lab so I could actually touch some of the machines like we're learning about in class, and also to work with solar cells because that's a big field in optics and science.
Every day, the Earth receives a huge amount of energy from the sun. And every day, we're getting better at harnessing that energy. New ideas are shared every summer as students from all over the world participate in the Solar Decathlon, a competition to see who can make the best solar-powered house. Soon, photovoltaic shingles for your house and light, flexible cells that can charge your stuff on the move will be everywhere. And someday, we might even have solar power beamed down from satellites. The National Science Foundation supports researchers who look at stuff we already know a lot about, like plants and solar cells, and think about them in new ways. New ideas that could lead to a brighter tomorrow.